I would like to welcome also to Dr. Sharma. You are very welcome. So, and I would just briefly want to show the agenda for today. Uh, Here is the agenda. So now we will start with the opening ceremony. First of all, I would like to ask Mr. Pradhan to short introduction, the intention of the meeting, then some welcome remarks of Mr. Sharma. Then also our the director Sebastian will welcome all us, and we will follow with a short introduction of all participants. Then Martin and I will present a few basic facts about our company. It's okay for you?
Yes, Stefan.
Okay, so please, Mr. Pradhan, could you introduce?
A very good afternoon to all our colleagues, and also good morning to the colleagues from Aerosoldu. I guess it's early morning for you all. And I also am very happy to see the overwhelming response from the region to participate in this training program. There were more than 60 participants, and I would like to thank you all for making time to attend this training program. This is a 3-day training, half-day training program. So actually, we had planned in person. However, but due to this pandemic, that we are conducting this virtually. And I would like to express my most sincere thanks to Aerosoldu for agreeing to conduct this training, that too without any cost. And this is the first time that we are doing this type of training virtually. So this would be a very good learning for us in our future training programs when if this COVID situation prolongs. Uh, a little brief about the program. ICIMOD was engaged in air quality work since 2000 as a part of Atmospheric Brown Cloud Project and Mali Declaration. But I'm happy to say that now we have a dedicated program on atmosphere, and this is one of the 6 regional programs at ICIMOD. The program has 2 initiatives: Atmospheric Watch, which focuses on studies that involve a higher level of social and scientific analysis, like measurement of field data, modeling, remote sensing, etc. And this gives us a base to plan the mitigation measures that help influence policies and strategies accordingly. And this training is also organized by this initiative. And Surendra Joshi is coordinating this initiative. You'll hear from him in the closing. Maybe Surenji, you can just put on your video to let everybody know who you are. And the yeah, and the other initiative is the Air Pollution Solutions Initiative. This is engaged in sectoral mitigation measures. We conduct pilots, behavioral change campaign, especially targeted to reduce pollution, and also it provides insight to policymakers and also to the private sector, because these pilots are focused to them on cost-effective solutions. And both the initiative, the cross-cutting area is capacity building, regional collaboration, and we also integrate gender and social inclusions. In South Asia, you all know this, owing to this high concentration of black carbon, be it in cities, industries like brick kilns or cement, agriculture field, or largest sources of fresh water, the Himalayan glaciers. It is considered to be especially vulnerable to the impact of black carbon from the standpoint of climate, also on health and livelihood too. Thus, ICIMOD has installed several monitoring stations with various instruments in Nepal and Bhutan to understand the pollution concentration for mitigation actions. And we have chosen Nepal and Bhutan specifically because in these countries, there were no monitoring station. There are cost-effective, high-impact opportunities to reduce black carbon, which can contribute to numerous sustainable development goals, such as cleaner and healthier air, food and water security, reduced mortality, and the mitigation of climate change. And to understand the scale of the problem, we have installed around 8 ethalometers from 80 meters to 5,000 meters altitude. And these instruments require regular servicing calibration to ensure quality data. Thus, we are having this training and will help in enhancing your knowledge, not only on operating the instrument, but also maintaining and calibrating it. And I'm happy to say that you are fortunate to receive this training from the expert who have given birth to this instrument. And I hope you may make this full advantage of it when you are receiving this first-hand training from the manufacturers itself. Apart from this, we have conducted trainings on gas analyzer and GRIM, and we'll be also developing a black carbon protocol for carbon financing with SCS Global and VNV for the BRIC sector, just to let you know. And I'm sure, we are doing this training for the virtual training for the first time, and this might be challenging. And even to arrange this training, my colleagues Praveen, Bhupesh, Suresh, Nirmala has been engaged extensively. I want to also thank them. And most of all, today we have our Deputy Director General, Dr. Eklavya Sharma. And this also shows our long commitment in the field of air quality. So without further delay, I would like to request Dr. Sharma to welcome the participants. So to you, Dr. Sharma.
Thank you very much, Vidya. Good afternoon from Kathmandu, Nepal, to colleagues from the countries of ICIMOD. Out of 8 countries, 6 countries are participating in this training. So it's really heartening. And I heard 60 participants are joining in this 3-day training. I would also like to really appreciate and express our gratitude to Aerosol Do, who has agreed to give this training. Wonderful. I would like to really thank you all for your excellent, I think, gesture for this this region where we have many developing countries and small countries. And if we look at the capacities, I think the capacities are limited in running equipments like the one ethalometer for black carbon. So from our point of view, I think this is one very good example of how the North and South can come together to look into the climate change and also look into the solutions in this region. And this is a very specific instrument for measuring black carbon, as was mentioned by Vidya. And if we look at the Hindu-Kush Himalayan region, our 8 countries, we have 240 million people living in the mountains. And about both mountains and downstreams, about 1.9 billion people. That means it's a huge human interaction is taking place with the atmosphere and with the mountains here. So in that context, if I look into black carbon as one of the pollutants which are quite critical for this region, black carbon source, and then as it moves to different parts of the Hindu-Kush Himalayan region, the movement, the meteorology, and how the air circulation takes place are all very, very critical and important. So in this context, I think we have to really understand a source from one country might lead into black carbon deposition somewhere else. So we have big countries like India and China who are also participating in this meeting, and Pakistan is also a big country, and then Bhutan, Bangladesh, Nepal, India, Pakistan, and China are participating here. So if you look at black carbon, I think many people in this region, until about 10 years ago, they were not understanding the health impacts of black carbon. Also the black carbon has other impacts. Glacier melt is another impact. But I would say in the months of winter, when we have inversion layer formed and there are winter fog situation, the black carbon which is emitted by biomass burning, they remain at the lower surface of the atmosphere. So then what happens, the concentration really increases, and it also actually prevents the solar radiation coming down to the land surface. That means directly impacting the food production, winter crop production also it impacts. So it's very important. It impacts human health. It also impacts food security issue in certain part of the year. So black carbon is quite critical and important, and I'm very happy there is a very specific instrument which is now with ICIMOD, 8 of them, and they will be operational. Our member country partners will be, I think after these 3 days training, will be able to use much more efficient use of the equipment and make better analysis for policy inputs. So this is what I think is quite critical and important. Now, if I look at ICIMOD's work, so Vidya mentioned, Dr. Vidya Banmali Pradhan mentioned that we have 6 regional programs, and one is very much dedicated to atmosphere. So atmosphere and air pollution has become quite critical and important. It is not only in this region. Some of the seasons, we also get the air pollutants coming from far away from Western Asia, as well as from other parts in this region. And from the downstream plains, I think we get a lot of air pollutions coming to the mountains. One of the big source, which is internal source in the Hindu-Kush Himalayan region, is that in the month of March, April, there will be lots of biomass burning. So that is the source we see, which is coming from communities. So awareness and working with the forest department, because lots of forest fires are also bringing black carbon to the atmosphere. So, and then they go and get deposited up in the glaciers as well. But I think the industries, we have large coal-based industries, other fossil fuel-based industries. They are also quite important source, not fully completely combusted fuel, and then they release lots of black carbon. So in this context, I think this training is very, very important, and I'm so happy that Aerosol is helping us in this, and we would like to see our partnership with you very much, and we would like to continue. Maybe some of the information data which we get, maybe we have to take your technical help to understand. And as I understand, I think time to time monitoring very much, and looking into the equipment performance by our colleagues. If there are questions, I think they will also come to you. But before that, we would like to see our partners very much fully aware and they have the skills to operate these equipments. Bhutan, of course, and in Nepal, I think where the equipments have been now installed, I think these 2 countries are mostly the recipients of lots of pollutants from outside. So in this context, I think if we are going to get good data, understanding the seasonality, that the diurnal variation, then also the altitudinal variation of the deposition or the concentration of carbon in the aerosol, air along the elevations. I think these are some of the things which will help in terms of looking into the systems, ecosystems, what need to be done else. Otherwise, even the livelihoods of the people, which is very much linked, and the health of the people, which are very much linked with black carbon. So without talking much, but I very strongly feel that mountains are inaccessible. But with this COVID situation, when we are doing virtual meeting, I think we are connected. I think there are good opportunities also when there are challenges. So now I'm very happy that we are virtually connected, and from all these 6 countries and our partners from Europe, to really make this training happen. So I'm very, very happy. Thank you very much. And all the participants, as well as Aerosol members, experts. And I would also like to thank our ICIMOD colleagues, Dr. Vidya Banmali, Dr. Surendra Joshi, and all others who are associated with this training. I really look forward that in 3 days' time, I think we will have some independence in terms of running the equipments and getting the data in the right way. I think very much sometimes what happens, you get the data, but unless and until the data is properly used and we make a logical analysis and get the inference of what is happening and feeding into the policies, I think that data will not have value. So I would suggest that our colleagues from ICIMOD side also keeps track of how we analyze, how we then make it in a simple language, and then how we reach out to the policymakers of our countries. With this, once again, thank you very much, all of you. I am very glad, very happy that we have such a wonderful partnership emerging. And then would like to also say that at the end of the 3 days, I think we will be able to get our colleagues preparing plan how to implement what they have learned in these 3 days, so that the training doesn't stop here. The training continues after the training also. This is, and I'll request our colleagues to trace how this training really brings benefit to others afterwards. So thank you very much. Once again, welcome, and I wish you a very productive 3 days training. And congratulations to all of you for starting such a wonderful work. Thank you very much.
Thank you, Mr. Sharma, for your speech. And now we will proceed with our director, Sebastian.
Good morning to everyone. I would like to welcome you from our side to this training. My name is Sebastian Marinic. I am a general manager of Aerosol company, and I have learned that there are attendees from 6 countries to this training, which is great. We are really honored to host a training that has attracted so much attention, and basically it confirms that the air quality topic itself, and especially black carbon pollution, is an important part of your daily lives and work. Just a brief introduction of Aerosol. Aerosol company is based in Slovenia, a small country of 2 million people. On one side, we may be a small country, but we do make great products, and we hope to also offer you in this training not only technical training, but also training that will help you to use the instrument in the best way, to use the data in the best way. As Dr. Eklavya Sharma explained, it's not only that you need good data, you need also good interpretation and use of that data, so that the policymakers can make better decisions. Our company is a team of 30 people approximately. We manufacture ethylometers, so black carbon monitors, OCEC analyzers, and total carbon analyzers, which my colleagues will explain about later on. We also, from the manufacturing, we also have a very strong research and development group, which represents 1/3 of the company. And our research group is one of the leading European organizations on the topic of research on carbonaceous aerosols. And aerosol is involved in many research and scientific projects, collaborating with institutions from Europe and elsewhere, which basically gives us also access to current research topics. And from what Dr. Eklavya Sharma explained is basically very known very known problems which are coming from the black carbon pollution. In some way, black carbon sources of pollution can be local, can be regional, but the effects of this can be again local, but also global. So this is our common interest to be involved with, and we're really happy to host you in such a great number. And I sincerely hope that this training will be useful for you and will help you in your monitoring applications, scientific and research applications that you are involved in. So again, I would like to welcome you again and wish you a constructive and productive training, and also any feedback from your side would be very helpful, so that because we have started this year more extensively to do webinars, and we are learning each time something new. So any feedback from your side how to improve would be helpful. Again, I wish you a successful and productive 3 days training. Thank you very much.
Thank you, Sebastian. So based on our schedule, now we will follow with the introduction of all participants. So I'm not sure how to do this because we are a lot of people. So I just suggest to unmute your mic for a while, and maybe also switch on a camera and just in a few seconds present yourself, if you agree.
Dr. Sharma, just to introduce that we have our Deputy Director from DOE, Induji, and also we have Tenzing Wangmo from NEC, Director.
I saw her.
Yeah, it's
I saw her.
Good
I know
commitment her. From, yeah.
And from Nepal, who I couldn't.
Induji is a Deputy Director from DOE.
Okay. So thank you very much, both our very esteemed senior officers. I think you can make things happen on the ground. Thank you so much for joining this meeting.
So Praveen Popala, working for ICIMOD as a senior aerosol scientist. I will call individual names and then they can give their designation and institution name. Thank you. Abhishek.
Hello everyone, I am Abhishek. I work as atmospheric modeling analyst at ICIMOD. Thank you.
Ajay Kumar.
Hello everyone. I'm working in Bihar State Pollution Control Board for the as an air pollution specialist. And thank you.
Thank you.
Please mention your country also, because Bihar is in India.
Yeah.
So mention your country.
Yeah, sorry. So, hello everyone, I'm Ajay and I'm working in Bihar State Pollution Control Board, India as a air pollution specialist. Thank you.
Amit,
Hello everyone, I'm Amit Bhujal and I'm working at ICIMOD as Trace Gas Measurement Research Associate, and we are taking care of the instruments.
Amitesh Gupta,
Hello everyone, I am Amitesh Gupta. I am working as assistant professor in JIS University, Kolkata in India. Thank you.
Anima Shrestha, Anima,
Let's jump to the other.
Anima has some technical problems with the audio.
Ashma,
Anima has some
I'm Ashma
technical.
Subedi from Kathmandu, Nepal, and currently I'm sorry.
go ahead.
Currently I'm doing my master's degree from Kathmandu University in Environment and Natural Resources with air pollution as research of interest. Thank you.
Thank you. Bhupesh, your microphone is muted, Bhupesh.
Hi everyone, Bhupesh here. I work as Senior Quality Specialist at ICIMOD.
Benaya,
Hello everyone, I'm Vinay Kisi. I work as an assistant professor at the Kathmandu University, Nepal. Thank you.
Chaman, Chaman, probably your microphone is muted. Okay, next, Fatima Jabin.
Hello everyone, my name is Fatima Jabin. I'm from Pakistan. I'm currently working as a PhD fellow with ICIMOD under the initiative Atmospheric Watch. Thank you.
Thank you.
Govinda, we can't hear you properly. Can you repeat again? Govinda, can you repeat again?
Hello everyone, I am Govinda Vasarnani. I'm working as environment inspector at Department of Environment.
Thank you. Indu, Indu Bikram Joshi. I will go next.
Hello.
Jigme. Yeah, okay. Indu, please go ahead.
Good afternoon. Good afternoon. I am Indu Bikram Joshi, Deputy Director General, Department of Environment, Government of Nepal. Thank you very much.
Thank you. Jigme.
Hello. Hello, I'm Jigme. I work for National Environment Commission, Bhutan.
Kashif Imran. We can't hear you, Kashif. Sorry, we can't hear you. There's something wrong with your microphone, maybe. Okay, I will go for next participant. Kinle Jam.
Hi, I'm Kinle from Bhutan. I work at National Environment Commission.
Kirtan Adhikari.
Hello everyone, this is Kirtan from Bhutan. I work as a lecturer in Royal University of Bhutan.
Thank you. Next, Lilu.
Hello everyone, I'm Lil Kumari Thapa from Nepal.
Thank you. Lobjang.
Hello everyone, I'm Lovjong Thempa. I work as an assistant environment officer at National Environment Commission, Bhutan. Thank you.
Thank you. Mukesh Rai. Mukesh. Nabina Mahajan.
Namaste, I'm Navina Morjan, working for the Department of Environment, Nepal. Thank you.
Thank you. Nibesh Rastra.
Hello everyone, I'm Nivesh Shrestha from Nepal. I'm working as an environmental engineer at Real Time Solutions. Thank you.
Thank you. Nimesh Chetri.
Hello everyone, I'm Nimesh Chetri. I work in the College of Science and Technology from Bhutan.
Thank you. Nirmala Budwa.
Hello everyone, my name is Nirmala Badwal, Program Associate for Atmospheric Watch Initiative, ICIMOD. Thank you.
Thank you. Parth.
Hello everybody, I'm Parth. I work as an air pollution observation analyst with ICIMOD.
Thank you. Pravesh. Pravesh. Okay, I will go with next one. Praveen Kumar. So you are muted. Praveen, you are muted.
Hello everyone, my name is Praveen Kumar Singh. I am working in ICIMOD as SSA Cryosphere and Atmosphere. Thank you.
Thank you. Priyanka Srivastava.
Hello everyone, I'm Priyanka Srivastava. I work at ARIES in Nainital as a senior research fellow.
Thank you. Rajeshwar.
Hello everyone, I am Rajeshwar Paudel, working in Department of Environment as an environmental inspector for the government of Nepal.
Thank you. Rashbin.
Hello everyone, I'm Rashfil Amsane, Honorary Graduate student at Kathmandu University. I'm currently working at NESFA regarding glacial melting. Thank you.
Thank you. Rishi Ram.
Hello everyone, I am Rishi Ram Swedi. I am working at National Trust for Nature Conservation from Nepal. Thank you.
Thank you. Sadaf.
Hello everyone, myself Sada Fatima and I am PhD fellow at ICIMOD. Thank you.
Thank you. Sagar.
Hello everyone, I am Sagar Adhikari. I am working as Air Pollution Emissions Research Associate at ICIMOD. Thank you.
Thank you. Samiha.
Hello everyone, I am Samiha Nahian, currently pursuing my master's from University of Dhaka, Bangladesh and currently working on indoor PM 2.5. Thank you.
Thank you. Sanir.
everyone. I'm Sanil Amichani. I'm working as conservation officer in National Trust for Nature Conservation, currently in Chitwan National Park, Nepal. Thank you.
Thank you. Shankar Prasad Paudel.
Hello everyone, I am Shankar Prasad Paudel, Senior Divisional Chemist working at Department of Environment in Pollution Control and Regulate Section, Nepal. Thank you.
Thank you. Sohib.
Hello everyone, my name is Shoaib from IST Institute of Space Technology, Pakistan. We have been working on the monitoring of aerosol for quite a time. So we expect to learn some data analysis and maintenance from this training course.
Thank you. Sohib Malik.
Myself, Sohaib Malik from Pakistan, and I am doing my MS research from Institute of Environmental Sciences and Engineering, National University of Science and Technology, Islamabad. Thank you.
Thank you. Surendra Raj Joshi.
Hello, my name is Surendra Joshi. I work as a program coordinator at atmospheric watch at ICIMOD. Thank you.
Thank you. Thank you, Surendra. Suresh.
Hello everyone, my name is Suresh Pokhrel and I'm working at ICIMOD as Aerosol Measurement Research Associate. Thank you.
Thank you. Shishir, I forgot, I think. Shishir?
Yeah, hello everyone. I'm Sisir Dahal. I work as SSA Air Quality Modeling at ICIMOD. Thank you.
Saida Mahanur Ali.
Hello everyone, my name is Saida Mahanur Ali and I'm a student of Environmental Sciences from National University of Science and Technology, Islamabad. I'm doing my research on black carbon content and using SPDART model in the cities of Lahore and Multan. Thank you.
Thank you. Tashi? Tashi? I will go with next one. Tenjin Wangmo.
Okay. Good morning and good afternoon to everyone. So my name is Tenzin Ongmo. I currently work as the Chief of the Climate Change Division in the National Environment Commission from Bhutan. Maybe just to inform our colleagues from the aerosol dole. From Bhutan, we are joined by 11 participants, 5 from the National Environment Commission and 6 from the 2 colleges in Bhutan. So we also have 2 of this equipment installed in Bhutan. So we are really looking forward to this training. So thank you very much.
Thank you. Thank you. Tashrin?
Hello everyone, I am Sring from National Environment Commission from Bhutan.
Thank you. Janit?
Hi, this is me, Zainab Irfan from University of Punjab, Pakistan. I'm doing PhD in environmental health and air quality. Thank you.
Thank you. There is one participant with unknown user. I don't know the person name. So that's all I think we have for now.
Okay. Thank you all of you for your brief introduction. Based on our plan, we will now proceed with the introduction of our company. We will just slightly swap, and we will start with Martin, who will introduce a few basic facts about our R&D, our research and development department. Please.
Yeah, so hello, welcome everybody. My name is Martin. I'm the head of research and development department here at Aerosol. So our department makes 1/3 of all company, and that's quite an unusual thing for the private company, and we're quite proud on that. So I joined Aerosol in 2014 after finishing my PhD at University of Ljubljana. So my, let's say, background is in the field of optics, nonlinear optics and lasers. When I came at Aerosol, firstly, I was working as a primal inventor of the new instrument that we have that I will also present on Friday. So the total carbon analyzer, but I also worked on various research and development tasks, like with the thalameter, the offline filters, and so on. So as for our department, there is 11 people, of which 6 hold a PhD in natural sciences or environmental sciences. And they're mostly working on, let's say, basic research involved in numerous international projects and also working on different designs of new instrumentation. And we also have other people, developers working in our department, which are working in the field of electronics, mechanical engineering, and software development. So cumulatively, altogether, we have, let's say, more than 100 years of experience in designing aerosol instrumentation, working, studying, doing different research, and of course also publishing papers. Recently we evolved, so we developed also some other instrumentation, and I guess we are now at the point where we can talk about multiple phases of carbonaceous aerosol. So our focus is still on the, let's say, aerosol absorption, black carbon, but we can also now talk about the, let's say, thermal properties of aerosol with the OCEC analyzer, with the total carbon analyzer, and so on. So I will talk about that on Friday. I will present some projects that we are involved in, also some studies that we are involved in, and I also invite you, if you have some questions or discussions or some special discussions for the Friday meeting. So with that, that's all from my side. I wish you a very fruitful training and see you on Friday.
Thank you, Martin. So we will now proceed with a short introduction of our company. I will use one PowerPoint presentation, about aerosol and Magi Scientific. I would like to also ask you to raise, if you have any question, raise a hand, and my colleague Clement will help me with your question, and we can actually answer immediately to your question. I would also like to point out here at the beginning that this is our first such a type of the online webinar about all our instrumentation, and so you can expect some troubles like communication troubles, and but I hope we'll not repeat too often. So let's start with just a brief introduction of our company. So our mission is to raise awareness of the carbonation aerosols by providing knowledge, like Martin already mentioned, providing systems and data that can lead to policies to make the environment more safer and more healthier for all of us. So Our vision is to be a leading producer and partner and provider of the system, services, and support to users in the field of decarbonation aerosols. And also our vision is also to have a leading research and development position in the segment of all carbonation aerosols. Our first attelometer we introduced in about 40 years ago. It was produced in the California, United States, and the McGee Scientific, like a company, start to produce and sell the attelometers or the black carbon monitors in the 1986. In the 1996, the production was moved to Slovenia, to Europe, and in 2007 we established the company Aerosol in Slovenia with the full R&D and production capabilities. Attelometer, the current version of the attelometer was introduced in 2012. Attelometer AE33, which we will talking about later on. In 2015, we start to manufacture. We were awarded to manufacture the DRI instrument. This is offline OCEC instrument. In 2017, we introduced a new instrument, thermal instrument for the total carbon measurement. And then in the last 3 years, or last 2 years, actually, we introduced CAS, Carbonation Aerosol Speciation System. It's actually a combination of the total carbon and attelometer. And with these instruments, we can measure the whole carbonation aerosols in ambient air. Last year, we introduced the new portable attelometer, AE43, based on the same technology like Big Brother AE33, but with a half of weight and with a half of dimension, with smaller. And this year we will introduce the new version of the DRI instrument, with some technical improvements of these instruments. This is, let's say, our portfolio, and this is our team. As we already mentioned, we are about 30 people now in Ljubljana, from R&D to the production, and so in the middle you can see also here in the middle is also our owner and also inventor of the DRI, the Dr. Tony Hansen. Our attelometers are all over the world. So from Antarctica to Arctica, from some deserts in Africa up to top of the Himalayas, last year we produced the 1,000 of the attelometer, and of course our network of the attelometer still growing. This is the last slide about this short presentation of our company. If you have any question, please. Otherwise, I would suggest just a 2 minutes break. Hello, do you hear me? And could we start now?
Yes, we can hear you.
Okay, great. So I hope we solved some technical issue. with this presentation and so on. So I would just like to ask you, because now we see that currently 47 people is on a list, but we invite 42 attendees is log in, but we invite 60 people. Should we resend some invitation for some, or is this normal?
I think some people came for opening, so they left. It's okay. We can start with the workshop.
Okay. So this first part of this training, this workshop will be about accelerometer AE33. The short agenda through this my presentation. Some basics about accelerometer and black carbon as well. Then we will proceed with some application example. A few words about EthNet. EthNet is a possibility to connect our accelerometer with the TCP/IP network. Installation, how to install, some basic facts, how you have to install our instruments and to proper measure. Really few words about user. Then we will go through the whole user interface on the instruments, and I will gonna tell also something about the data structure, but much more about the data. You will have tomorrow when the whole day you will spend with how to analyze the measured data. Something about we will proceed with something about the quality control. So how to check periodically check the instruments, check if everything is okay, up and running, and the instruments work properly. And then we will have, of course, some discussion. And as I said, you can ask via raising hand or via chat immediately. My colleague Clement will help with the answer, or I will answer immediately during the course. So accelerometer is instrument for the black carbon measurement. And what is a black carbon? Black carbon is, of course, aerosol, small particle in the ambient air. And it's produced by incomplete combustion of carbonation fuels. So on one side we have sources of the black carbon, then we have some characteristics about black carbon, and we have some effects of this black carbon. Sources are like on these pictures we have, especially in our country, is very important and very huge, this biomass burning. And we have some special events like forest fires, wildfires. These are special events, but in the, let's say in our world, one of the very significant source is the traffic with which use mostly the fossil fuels. Then this aerosol has some characteristics, like could be fresh, could be old and already coated with some other elements, and has some effects. What is maybe more important is that black carbon absorb light, and with especially this effect that absorb the light, we use in our instrument to measure the concentration of the black carbon. On this next picture, we have just introduction about formation of the black carbon during the combustion. So in first 50 milliseconds, we produce very small particles, which are fractals between 10 and 30 nanometers big, and this is later on, of course, this aerosol could be also bigger. What is very important for the black carbon emission is that the black carbon emissions is highly unpredictable. So if you know how many fuel we burn it, we don't know much about how many black carbon we emitted, because the emission of the black carbon is related to the quality of combustion, and we don't know much about the quality of combustion. Just for as an opposite to the CO2 emission, which are highly predictable, because we just need to know how many fuel we burn it, and because from 1 kilo of the fossil fuel we always emitted the same amount of the CO2. So black carbon, and this is very important for us, is highly unpredictable. So we cannot know in advance how many black carbon we will emit during the combustion. Double role of the black carbon. Black carbon has two main roles. One is health effect, because the black carbon is very small, can penetrate even to the blood, because the particles smaller than 100 nanometer can penetrate deeply in the lungs and even in a blood. So this is one very important issue of the black carbon. Second is of course climate effects, and you probably know much more about these climate effects, but the latest research shows us that total BC forcing is about 1.1 watt per square meter. And of course, all these properties of the black carbon lead us to our final conclusion from Lord Kelvin, as Lord Kelvin said a lot of years ago. If we want to measure, if you cannot measure something, you cannot improve it. And because we want to improve the situation with the black carbon in our environment, we have to measure black carbon. So, and that's why we produce a thermometer like one of the. So we think the most advanced black carbon monitor on the world currently. So black carbon is our ethylometer for the black carbon measurement is about 40 years old. Also, the principle of the measurement is 40 years old, and the principle is quite straightforward. We just draw air sample continuously through a filter, and we collect the aerosols on the filter. Then we illuminated this filter, and we measure the optical transmission through this filter and then we calculate the attenuation of the light on this filter. We know that attenuation is proportional to the black carbon to the amount of the black carbon is loading on the filter, and then out of this with some calculation, with some math, we can calculate the concentration of the black carbon in air stream. So this is the principle. And here is the, let's say, schematic about the ethylometer. We have a light source. Now we have light source with 7 different wavelengths. Then we have filter sample. We have, of course, 2 parts of the filter. On one part we have a spot with the black carbon on it, and we have, of course, also the clean area of the filter. Then we have two detectors, light detectors, one behind of the black carbon spot, and second one on the behind the clean part of the filter. And with the signals, we can calculate the attenuation in delta attenuation in time period. we assume that attenuation, the delta attenuation, is proportional to absorption factor, absorption of the absorption. As I said, we measured with the 7 different wavelengths, so from 370 nanometers up to 950 nanometers, and we do all this in a real time. So our sampling period is 1 second, and reporting period is 1 second or 1 minute. And here is the some equation. So basic equation. Basic equation is the black carbon concentration depends on the surface area on the filter, delta attenuation, flow through the filter, time, and mass absorption cross-section index for the air. So this is the basic equation, but of course this is the ideal equation, because we don't measure the attenuation only through the air, but also through a filter. We actually have to use the mass absorption cross-section, or sigma, of filter, and this sigma filter is actually mass absorption cross-section of the air multiplied by one so-called multiple scattering parameter of the filter. This C is for the filter which we currently use 1.39, and of course this C directly depends about the type of the material of the filter. Later on, I will a bit detailed explain about the compensation. So the attenuation is not directly linear with the amount of the black carbon material on the filter. That's why we have to compensate all results. So with one factor K. We can do this with the post-processing when we already know the absolute attenuation, or we can, in our instruments, we do this with one special and patented method in a real time. So loading compensation. We will see much more about this a bit later. Then we have also some, because the instrument is not ideal, we have some leakage in flow, and we also need to, in final equation, we also need to include this leakage. We can measure the leakage periodically with some method here, but currently the leakage depends about the type of the filter, and this filter which we currently use has about 1% of the leakage, so the leakage is very small, but needs to be also involved in the final equation. So with all these add-ons, the final equation for the black carbon concentration in ambient air looks like this. So it's not very complicated. What is important, so we have some constants, like surface area is constant, sigma air is constant, this factor C is constant. Also the leakage factor is constant during the measurement. So we have to measure the attenuation, and the K factor should be measured all the time. Okay, so this is the equation. All these parameters could be found also in our instruments. Let's say, for instance, the surface area is fixed, and you can find in the setup files. basic concentration is on the main screen of the instruments. Delta T or time base is also on the main screen. Then delta attenuation, you have to calculate it out of this table, which is on the data tab. Then you have here all information about the flow. Also the K factor is here, sigma R, and leakage factor, and the multiple scattering constant for the tape is also. So all these are here in somewhere in the user interface. Here is the flow diagram for the instrument. So there we have just shortly. So here is the main part is here late source with the 7 different wavelengths. Then filter. Then we have here spots with the black carbon. We have actually 2 spots, why I will describe a bit later. Then we have 2 spots with the black carbon and 1 reference spot where is no black carbon on the filter. And we have the detector with the three detectors. And so there is 4 valves there are 4 valves in instruments just to
I
lead.
think the slides are not changing.
Sorry?
I think the slides are not changing.
No.
What do you see? Do you see flow diagram?
No, we see only basic equations.
Really?
I see flow diagram.
Yeah, because it's changing.
I also see flow diagram. Yeah, it is changing.
Yeah, I also see flow diagram changing.
Okay, must be an issue, right? Okay.
It's okay?
Yeah, please go ahead, Stephen.
Okay. So this is the flow diagrams. As I said, we have 4 valves here. These 4 valves are because we want to lead the flow on different paths through the instruments. If everything is normal, I will describe just two situations. Let's say if everything is normal, then we draw the flow like this, and then through valve number 4, here we have flow divider. We divided our flow to 2 different flows, one through spot 2 and one through spot 1, and then goes through here through the mass flow meter to measure the amount of the flow, and then through the pulse damper and pump to the outlet. So this is the, let's say, this is the way of flow during the regular measurement. So because we have some tests to check with the instruments, if with instruments is everything okay, and for instance, let's say when we perform the clean air test, in this case we closed this valve number 4, put to position 1, and we open this valve number 3 to 1, and then the flow goes like this. So here we start the ambient air, go through the filter. This filter, this is the particle filter, and with this filter we completely remove all particles from the air, from the sample, and then the free of aerosol sample goes like this, and with this on the same way then later on. So, and we can check with this test, we can check the noise of the instruments. We expect during the clean air test, we expect that we will measure concentration close to 0. We will measure just the noise of the instrument. So this is, let's say, one example how we can change the path of the flow through the instrument. And we have also different other tests like mass. When we calibrated the mass flow meters, we again changed the flow through the instruments to just to measure just to calibrate mass flow meters. So that's why we have 4 different valves here. But this is the basic flow diagram of our instrument. So now I will proceed with a few technical aspects or a few technical details of our instruments. What is, let's say, important for which technical aspects are very important for our instruments. One of the maybe more very important is this wide dynamic range of this instrument. So, and on these 2 charts, we have 2 different examples. One is taken in Berkeley, California, where is, especially during the summer, very clean air. And we measure with the instrument the concentration of the black carbon about less than 50 nanograms per cubic meter. And second case, let's say, is from the Calcutta in India, where we measure the concentration higher than 100 microgram per cubic meter. Means that between these 2 examples is more than 3,000 times difference. And we did this with the exact same instruments without any exchange on the inlets or something like this. So this wide dynamic range of the instrument is important for such a measurement, and we are really very high with this dynamic range of the instruments. Second technical aspect is what is also important is this, let's say, the real-time measurements. We can measure. So the instruments measure with 1 minute or with 1 second of time base. Here is, let's say, one example, which is here we have already averages of the 5 minutes averages of measurement in close to the one street in one location in London. When with some post-processing, we got this type of the charts, and what we can see here, we can see some pattern that we have these morning peaks during the work day, especially Monday, Tuesday, and Wednesday, and then we can see that we don't have this morning peaks during the Saturday and the Sunday. So with if you want to observe this diurnal profile, then you have to have this as much as possible data, and this time base with 1 second assure you that you can really find some patterns in concentration during the day, during the sun period. So because our period is very short, 1 minute, so you are able to find maybe some interesting patterns in concentration of the black carbon in the air which you measure. This is also, let's say, very important. Then this is maybe most innovative feature of our instrument, loading effect compensation. As I already said before, when you collect the aerosols on the filter, this spot became darker and darker, and after a certain time you have to move to the fresh spot. You need to perform so-called new tape advance. But what is important inside of the one period, inside of the one tape advance period, we observed that the response is not directly linear. So with the highly attenuation, you will measure lower concentration of the black carbon. So it's not directly linear. And on this chart, you can see here, so the black one shows a non-compensate black carbon concentration. The red one shows us the compensated data, already compensated. And what we can see here, and this is the event, this is the time when you move to the fresh spot, and then in the non-compensated data you can see this big jump, and also here again big jump, while in the red line, which is already compensated, you don't see this jump. So this is because the response is not linear, and when you change to the fresh spot, when you change the filter, you will in case of the non-compensated data, you will see this big jump. So, and here is the equation. So the reported BC must be compensated with the BC at zero loading, and you have to introduce this K parameter. K parameter is well known, so you can find more details in this scientific paper from Virkula. But of course, you can do this with the post-processing. In our instrument, we so with the disk K, you will actually simulate it. You will change the slope to the linear one. That the attenuation will be linear with the concentration. So our solution for this, let's say, problem is the dual spot method. With the dual spot means that we have inside of our chamber we have a split divider when we split flow to two different spots, but not but in ratio that we have 2/3 in one spot and 1/3 to the second spot. Because this we have on the tape always two spots. One is darkened and one is lighter. This is normal. And when we measure when we calculated the black carbon from darker and from the lighter, we will find two different concentration because this non-linearity. And out of this non-linearity, we can calculate the K parameters. And what is very important, we can calculate this K online. So we don't need to wait and do this with the post-processing. So we can calculate it immediately, and we can include this calculated K directly into our equation for the calculation of the compensate BC. And with this K, then we calculate the compensated black carbon concentration, and without any jumps. And like we can see, so here we see after changing the spot we have these jumps, but on the compensated BC these jumps are not visible anymore. Okay, so and this is, let's say, the final schematic of our instruments. Still light source with the 7 different wavelengths, but not just one spot, but 2 different spots, and with the black carbon and three detectors, and then we calculate black carbon concentration on the spot 1 and black carbon concentration on the spot 2. Everything else is the same. I would like to mention that this dual spot is patented, and of course we are the only producer on the world which can use it. This is really, let's say, one of the big advantage of our instruments, that all data are directly compensated, and there is no need for the post-processing. This is especially important if you want to I don't know, to immediately present or to use the data on some web pages and so on. It's no need for any compensation for any recalculation of the concentration. Okay, so based on this K measurement, we have also one additional feature of the instruments. So here on these charts you can see the K factor for different wavelengths. So we calculated, of course, the K factor for each wavelength separately. So we have 7 different K factors, from 370 nanometers up to 950. And then if the slope of the K factors goes like this, so that we have higher K with the higher wavelengths, then this means that you measure the fresh aerosols. If you have slope of the K factor like this, means that with the higher wavelengths you have lower K, then this is actually means that you measure some old black carbon which are already coated with some other materials. And more about this you can find in this paper from Drinowitz. This was published a few years ago. So this is one of the very interesting benefits of these K factors directly in our instruments. Here is also similar feature where we here observe just the K factor of the 880 nanometers, and so this is the time series of this K factor for the 880 nanometers, and we compare this with the measurement of the ACMC instrument, and we find out completely similar pattern of the K and the ACMC. And again, this maybe help you to discriminate between fresh and old black carbon. Where you have the high K factor at 880 nanometers means you measure the old aerosols with some coating, old black carbon with some coating on it. And when you measure the low K factor means that you have fresh and very local black carbon aerosols. A few more words about the loading effects is this algorithm is very sensitive, especially to the temperature and humidity. So and this is also true for in general for the measurement. So if you want that instrument will measure properly, then you have to warm up the instruments to the room temperature. So if you bring the instruments into room, you have to wait for a while that the temperature of the instruments is the same like the room. So you cannot change the humidity very fast, and also the temperature need to be as stable as possible. And it means that it's not very useful if you have the air conditioned equipment close to the instrument. Default also, so that this K factor is very small, and the default and has some limitation. So K minimum and K maximum between 0.005 and 0.015. But expected values for the K are between 0 and 0.001. So this is a few additional information about this K factor. Last feature which I want to mention is the source apportionment feature. So we can, with the instruments, we can, with our instruments, we can also distinguish between either the source of the black carbon is the diesel fuel or biomass smoke. This is done with the, because this could be done because we have seven different wavelengths, and for this we have to measure absorption coefficient, and for the pure black carbon, the absorption the absorption coefficient is related with the wavelength. But in general, we have to calculate an angstrom exponent out of the absorption coefficient at different wavelengths. So we have, when we put absorption coefficient on this chart, we can find this angstrom exponent for these curves. And if the angstrom exponent is close to 1, this means the source of the black carbon is in diesel fuel or fossil in diesel fuel. Yes. If the angstrom exponent of this curve is close to 2 or even higher, then means that source of the black carbon is the biomass smoke. Again, our instruments directly with the online calculate this angstrom exponent, and you can immediately know how many black carbon came out of diesel and how many out of biomass smoke. This is, let's say, this curve is a typical curve for diesel black carbon, and the curve is typical for the biomass smoke. And so if you have this biomass smoke percentage, which is reported in our file, then you can prepare the charts like this. You have here, you can see, so this is the urban background location here in I think here in Slovenia, where a lot of biomass smoke we have in ambient air, and so means we have here a lot of red color in our chart. Here is the one in the intersection in the center of the Ljubljana, our capital. Of course, there is a lot of traffic, and and we can see here much more black color because much more black carbon comes out of the traffic. So here are just let's say short about our ethylometer. Our ethylometer uses multiple wavelengths, and we measure absorption from the ultraviolet up to infrared wavelengths. Then we have really high dynamic range. We have also the loading compensation. This is done with the dual spot technology, which is patented, and we can do this in real time. Then we have some automated quality assurance and quality control tests with zero optical span checks and flow calibration. We will see this more later. We have really improved performance with the low noise, fast time resolution with the time base down to the 1 second, and our instrument is quite easy to integrate into networks and easy to communicate it with them. And more about dual spot technology we can find in this scientific paper. Do you have any question this after the first part? Or we should proceed with the application examples?
We can proceed.
Okay, if there is no question, then just a few words about application examples. I have here a lot of slides, but I will just go through briefly, because you will later on a Friday you will much more discuss with Martin about the application which are able to be performed with our instrument. Okay, so our instrument, our telemetry is used in different application with a different type of the customer. So let's say source apportionment to measure the source apportionment of the black carbon is very typical for typical application. Then we have a lot of application which are somehow related with low emission zones and are related with the transport abatement and so everything with related to the traffic. Then we have some application connected with the local and the regional transport of the air pollution, and then we have a lot of studies about emission in some different environment. Our customer are some national air quality networks, local authorities and national meteorological authority, some academic users, and in the last period more and more often also some industry. Let's say I will just briefly point out few our biggest customer or user. One is the National Air Quality Networks in United States. They have more than 20 telemeters installed over the Great Britain or England. They measure source apportionment. They also measure ship emission, traffic restriction, and regional impact. Then here is one network from the India with approx 42 stations, is so-called ARFI network, aerosol radiative forcing over India. Then we have second very big national air quality networks in India, IMD. They have also over 16 stations now, and here are, let's say, just listed all countries, not all actually, the countries which have in national air quality networks already installed our BC analyzers all over the world. Then from the, let's say, local authorities, we have installation in a few big cities like in Paris. They have also some mobile station. Then we have quite a huge installation in Iran, in Tehran, of course in London also. They are always related to so-called low emission zones in the center of the cities. Then here is maybe one very interesting situation when we want one application here in our capital. So there was the initiative to close the traffic in the center of the downtown, and with the discharge we can see that after the closure, after they closed the center for the traffic. There was the 70% less black carbon in air after the closure. And the same time, we have also on the bypass one control instruments. We didn't observe any increase of the black carbon on the bypass side. So this is, let's say, one of example how we can measure and how to improve of our environment. One very interesting application is also measure emission factor measurements. If we can combine our ethylometer with the CO2 sensor, and when we measure CO2 and the black carbon, we can calculate emission factor. Emission factor is proportional to this ratio between black carbon and CO2. And this is, let's say, quite nice application, interesting for the local authorities. And one of the implementation of this emission factor measurement is also this car chasing project. The project was named Mercedes. We chasing the cars and we measure the emission and we measure the black carbon concentration behind the car and CO2. And we can calculate again emission factor, and we can find super emitters. Some cars or trucks need to be repaired, which need to be repaired. Then this is also very popular for the local authorities. The project was done here in Slovenia. If you in some region if you install more than just one instrument, you can prepare charts like this, like live maps about the pollution concentration in cities or in the biggest area. With some improvements or with some nets, you can also do some forecasting about the concentration in the next few hours. So this is maybe also very interesting. Nowadays we can find a lot of these live maps around the world also with the black carbon concentration. We are very proud that also Google streetcars are one of our users. Currently we have about 10 Google cars is equipped with the ethylometer, and they constantly measure the black carbon concentration in let's say in London. In London there are three different cars which constantly measure the black carbon concentration. Then we have also one project in Netherlands and one project in United States, where these Google cars produce some nice data about the black carbon concentration. Academic users, we have a lot of course, one of the very big group of our users are academic users, and here is one example from the Brazil, where we have in this Max Planck Institute established this observatory in the middle of the Amazon forest, with, of course, not just with the black carbon measurement, but also with some different measurements. But as I said, very important group of our users are academic users. Academic users also, like you, measure the black carbon concentration in some high altitudes and some high installation. This year, or actually at the end of the last year, we also introduced special version of our ethylometer, which can work or measure up to 5,000 meters above sea level. So we integrated external pump to assure also working on higher altitude. and this I think could be also interesting for you. Also, so we were also part of the very let's say marketing, very highly covered marketing project, where one of our pilot measure with the plane concentration about 3,000 meter high in several campaigns over the world. And as I said, in the last period we have also the some industry users. One sample is here, where one of they measured the black carbon concentration in one mining facilities. Okay, much more about the application which are available. You can also find in our web page. There are a lot of papers describing different types of the application where our instruments are used. Okay, any question about application? No. So then I suggest just to proceed with this ETNET. This is a very smart chapter, and then we will have a small break. ETNET is one of the possibilities of our instruments to have remote connection with the instruments. There are three different steps or three different type of the remote connection. One very basic is this IE accessors. If you install one special application to your computer and you have TCP/IP communication between instruments and you, then you can directly communicate with the instruments, and you can directly change all settings on the instruments remotely. This is very useful. But in this case, you cannot download the data from the instruments to your computer. So the application is just like a screen mirror or screen mirror from the instruments to your PC and to manage the instrument. Second possibility is so-called ET alerts. If you connect your instruments to the internet, to the public internet, and enter the server address. Server address is here in Ljubljana, and send us the one email address. Then we can send to any email the status, the accelerometer status, and we can report some issue to any email worldwide. So you have to connect the instruments to the internet, set some settings, and send us the email address to which you want that reporting status will be sent. This is also very useful, especially if your instrument is far from your location. Then, in case something went wrong, you will immediately receive the email. And the last option is the ETNET. In this case, we can prepare the whole server, which will collect the data from the several instruments. And on one side, on the second side, you will be able to connect with the computer to this database, and you will collect the data, also control the instruments. All this is possible. This server could be yours, but also in last period it's very popular that we offer so-called cloud solution, where the server is here in Ljubljana, and you have connection to server on one side, and all your instruments have connection to this server on the second side. And but there is no need that you have owned your server here. This is very useful. I have here just a few screenshots from let's say from server, how it looks like. So one square present one instrument. If it's green, then with the instrument is everything okay. If it's yellow, means something is wrong, but it's not crucial. If it's red, then instrument is stopped due to some problems. Here are some charts which are also could be produced with this server. This is the remote access, how it looks like the application if you have these AE accessors. So it's directly mirror of the picture on the instruments to your computer. And this is how it looks like 8 alerts, how the report looks like when you receive the email. You have instrument, so you have a report about the status of the instruments. Let's say in this case everything is okay, so you have just all is green. And in case something is wrong, then you will immediately receive the instrument is stopped, and you can check instruments. So this is the end of the chapter number 3. If there is any question, please welcome. Otherwise, I would suggest 15 minutes of break. No
hello,
questions?
I have a question.
Yes, please.
Yeah, it is about the temperature sensitivity of the instrument and how it works on high altitudes.
So our instrument, basic version of the instrument can work up to 3,000 meters above sea level. If you want to go higher, then you need external pump. So last year we introduced the external pump, which is directly integrated in the instrument. It's not integrated mechanically. This is the pump is outside of the instruments, but we control the flow with the same flow meters. And you can even seamless, so our instruments can even seamless change from external pump to the internal pump. And with this external pump, you can use the instrument up to 5,000 meters above sea level. So if you want to use this external pump with the already existing instruments, there is need. So you have to send these instruments to, let's say, to repair in Slovenia, and we will add some small controller for the external pump into instruments directly. If you purchase the new instrument, then you have just to tell us that you need this high altitude version. This is one thing. So we have to add some controller inside of the instruments. And second is that we have to deliver this external pump, which is then you just connect this external pump to the instruments. Is clear?
Okay, thank you.
Okay. Some more questions?
Hi, Stefan.
Yes.
Yeah, if you could go back to the slide where you showed let me just hold on. Where you showed the source appointment of source apportionment between the biomass, smoke, and diesel. Can you go back to that slide?
Just a second. This one.
Yeah. If you could explain this slide to me again, please.
Absorption factor should be is in relation with the wavelength. So when you measure the concentration of the black carbon, you can also calculate the absorption factor. And absorption factor is in such a relation with the wavelengths, and with such a relation with the wavelength. So is 1 divided by wavelengths with power with the angstrom exponent. And then, so when you plot this absorption factor on the chart, you will find out the picture like this. So this the bottom line is very typical line for diesel black carbon. And in this case, the angstrom exponent is 1. It's close to 1. So if you will measure the black carbon, which is where the source will be diesel, you will find such a curve. If you will measure the black carbon where the source is in biomass smoke, you will find the curve like this. So the angstrom exponent will not be 1, but would be close to 2 or even higher.
Okay.
So now,
thanks.
Our instrument constantly calculates this angstrom exponent. And so of course, in reality, you are always somewhere between 1 and 2, because in reality, you will always test diesel black carbon and some biomass. And knowing the angstrom exponent, you can then find what is the ratio between these two sources.
Thank you.
More question? No. If it's not, then I suggest 15 minutes break, and then we will be back.